Okay, so today we're going to look at the matter and energy resources. We're going to do an overview of chemistry. We're going to start first of all with matter. And matter is anything that takes up mass, or has mass, and takes up space. And it's found in two forms. You can have elements and you can have compounds. And also you can have mixtures. Elements and compounds. Basically, a compound is chemically combined. That's where two things go through a chemical reaction to form this compound. But a mixtures are where they're physically put together so you can easily separate them. Okay, and here's a diagram to show solid, liquid, and gas. That's going to be important later. When we look at energy, a solid is very compact, tight together. Liquids are kind of a little bit moving apart. Notice with gases, there's a lot of space in between each of the particles. Atoms, again, are basically the unique smallest thing that can't be broken down. It is particular with the elements. In fact, atoms and elements have the same characteristics. It's just how I view atoms. Atoms are like your counting units. If I were to open up a bag of M&Ms, we have brown M&Ms, we have blue M&Ms. If I were to count blue M&Ms and I have 20 M&Ms in there, I would say I have 20 atoms of blue M&Ms. Blue M&M is an element. The 20 is the counting unit. When I come down here to the molecules, it's the same thing. It's like the counting unit. I might have 5 molecules of the compound water, H2O. So again, molecules and atoms are the counting units of elements and compounds. Ions are your charges, and remember, it's where electrons could either be gained or lost. If I lost electrons, it would be positively charged. If I gain electrons, it is negatively charged. Okay, remember, your protons stay consistent. You're just gaining or losing those electrons. When we look at our atoms itself, the protons and neutrons, they're found in the nucleus, and electrons are floating around, okay? And this is showing you the structure of an atom, where the protons and neutrons are located in the nucleus, and electrons are floating around in that cloud area. Your atomic number is the number on top, and it identifies how many protons that are in an atom. And also your mass number, the big number at the bottom, is the total number of protons and neutrons. So if you want to find neutrons, you would just subtract your atomic number from the mass number to find the number of neutrons. This is a periodic table of elements, and here you can see on the left side, the pink are all the metals. The green, these right here on the stair-step line, these are your metalloids, and these over here in the yellow, they are your nonmetals, but also note hydrogen is also a nonmetal, okay? The only reason why it's over there is due to the one valence electron in the outer shell, or in its only shell. All right, so all compounds basically are not necessarily organic. You have some inorganic compounds. So inorganic compounds basically are non-living, like salt, table salt that we put on our food. Sodium bicarbonate is baking soda. And also we have some covalent bonds, because you think, nonmetals, could they be organic? Should they be organic? Is the main component carbon? Now, carbon dioxide down here is what we breathe out, but it is in the form of inorganic, okay? Nitrogen dioxide, sulfur dioxide, those are compounds we're going to touch a lot in this class. And of course, ammonia. All of these are covalently bonded together to nonmetals. In an ionic compound, there's a lot on here, but just to put it in a nutshell, it's a compound between a metal and nonmetal, and electrons are basically transferred from one to the other. One gains, one loses electrons in order to be chemically stable. I'm going to jump on this one with 3 elements to know. Oxygen's number 1. These are inorganic compounds that are found in our Earth's crust. So oxygen is number 1, silicon's number 2, and aluminum up here is number 3. There are others, but these are the top 3 elements that are found in the Earth's crust that are found in inorganic compounds. Okay. Non-metallic elements, again, nonmetals, are those that are in the gas form. For the most part, most of them are in the gas form, but they are located to the right of the stair-step line. Okay. Covalent bonds are between two nonmetals, and they are actually very strong bonds, but they also can be between the super 7 elements. That's a compound, where maybe two nitrogens will bond together, two chlorine atoms can combine together. There's a lot that basically can form. They are sharing electrons, so it connects together. Again, as I said, two nonmetals, and they have similar electronegativities. Let's see. But again, right there, they share the electrons. All right, so organic compounds are basically, they're found in living things. To identify an organic compound, number one is usually carbon atoms. Okay, we have hydrogen, oxygen, nitrogen, sulfur. All of those typically are going to probably combine with some carbon atoms to make it organic. Here you can see hydrocarbons, chlorofluorocarbons, or CFCs, and then also some of the carbohydrates that are found in our foods. Carbohydrates, lipids, proteins, DNA, all of those are simple carbohydrates. And these are just some atoms. I'm going to go through it real quick. We got hydrocarbons, CFCs, the carbohydrates, the proteins, the lipids, and the DNA. These are just models, computer models showing these compounds or these elements in there. And again, as I said earlier, the Earth's crust, the elements up there are oxygen, silicon, and aluminum. Our matter quality basically is very important to us. We want to make sure that it is very useful. High quality matter means it's probably going to burn really intense. It's going to give off a lot of energy in that form. Usually high quality matter is in the form of a solid, whereas low quality is disorganized, it's real loose, it's real not tight together, that can easily give off energy or produce energy. So therefore, low quality would be like in a form of a gas. And here again, notice the models and my reference to the solid and the gas. High quality, dense, compacted together, low quality, spread out. And our energy right here is the ability to do work. And it can transfer heat. But when you look at our energy that we have here, we're focused on kinetic and potential in just a second. But you also have thermal energy giving off heat, electrical energy producing electricity, chemical energy where two elements are going to probably chemically combine together to form compounds, and nuclear energy is where I'm either going to split or fuse together those atoms or elements in order to produce high quality energy. Okay, so let's look at kinetic energy. Basically, everything is either going to transfer back between kinetic and potential. Kinetic is when things are moving, a car running, someone walking down the hall. That is kinetic energy. A roller coaster, that would be kinetic energy. When objects are in motion. Okay. But whereas potential energy is the energy is being stored, an object's just sitting there, has the potential to move, but it is not at that point. And the electromagnetic spectrum is showing energy that is produced from the sun and how it travels through space. We can't see it, but it does move, and particles that are traveling, the fastest are over here. They have a high frequency, short wavelength, and that would be the cosmic or the gamma rays. And as you move in, when it enters the Earth's atmosphere, it is bent at a point where it actually produces light that we're able to see. And that's the visible spectrum. But then you have these other areas down here. It gets slower and slower and slower longer wavelengths, lower frequencies. And to identify that, frequencies are how many waves pass in a given minute or a given second, excuse me. Here we have again our energy quality, very high. These are examples: electricity, fission, I'm splitting the energy there, our concentrated, really concentrated sunlight. And here you can go down to high, moderate, and low. These are just given examples of each. Please note in the book some of the examples that they have when reading. The law of conservation of matter basically says matter can neither be created nor destroyed. Okay? So it says in a nuclear change, the total amount of matter and energy involved remains the same. So basically what you put in is basically what you get out of it. Okay? When we look at radioactive decay, that is where elements basically will, over time, change into unstable isotopes. These are very unstable, but they do produce a lot of energy. So therefore, the nuclear radiation is producing a lot of energy. This is just showing alpha, beta, and gamma particles and what it takes in order to stop those particles. The paper for alpha, wood for a block, and this is actually a 3 meter thickness of concrete, or you could just have a thin lead wall to stop that. Fission, real quickly, is where you split the atoms. You're going to split it. Notice one big particle splitting into 2 smaller particles. And fusion is where you take 2 small particles and fuse it into a bigger one. And let me go back. And fission is what's done on nuclear power plants on Earth, whereas fusion is what's seen or observed with the sun. Okay? Very unstable on Earth, very limited places where fusion actually has occurred. The first law of thermodynamics states that energy can neither be created nor destroyed, but you're basically going to convert it from one form into another. You're going to go back from kinetic to potential and back to kinetic, vice versa. The second law states that here we have this energy and I'm changing its form, but in that instance, heat's given off. Okay? We do have, when we look at us as a society, the more advanced societies typically are very wasteful, whereas developing countries are not as wasteful. This is just showing us and our use of energy. Low waste societies are typically those areas that minimize or use their resources. Go back and check that out. If you have any questions about this PowerPoint or about any of the chemistry, please be sure to email me any of your questions or concerns. Remember, there is a quiz, and the quiz is on Monday. Bye.